Well, here is something I had not anticipated. You see on these valve guides how they have this tower and flange that sits down against the head and then locates the valve spring in the proper area around there. One of these was sticking up just a little bit. So I thought, well, that's no problem. We'll just take a driver here, which happens to be an old socket, go over the top of there, and I'll put it over in the press and press that down in. Well, guess what? When I pressed that, it was tighter than I thought it would be, and I broke that flange off there. It just bang, and I had all these little pieces. So now I just created myself more work and more problems, because as you recall, I have actually two pieces in there that make up my new insert valve guide, and they're butted together right up here in this area. I don't like that. That could finish breaking off the way that is now, even if I did manage to put something around here to locate the spring. So I think I'm going to have to remove this guide that I put in, and I'll go out in the lathe and I'll turn myself a piece that looks similar to this tower on the top here, and when I reinstall it with a new insert in there, I'm going to put my splice down on the other end, so that 1.25 inch long piece will be on the down on the combustion chamber side, and the 3 1/8 inch portion of guide will be sticking up above here so it can bridge this area and give it some strength. So hate it that happened, but things happen, and all you can do is move on, figure out what you got to do to make it right, and take care of it. So here we go. Okay, so we got the head with the bad guide mounted back on the guide machine here, and I think I want to go in. This guide measures 4 3/8 inch long. I think I'll drill down in with my core drill 3 7/8 inch, so that'll leave a 1/2 inch of the guide down on the bottom side. It'll make the rest of it just paper thin, and then we can go in on the bottom and drive all of this back out of there so we can start over again. So I'm going to go down in. You can't see it on camera, but I'm going to zero my DRO up here, and I'm going to drill down 3.875, 3 7/8 inch, and we will stop at that point. So there we are at 0, and going through. .75. Okay. Sometimes those pieces coming out can be kind of sharp, so I'm going to put a rag over the end of it here. There's the first piece out of it. There we have it. Top part of that guide came out. Get a hold of a pair of pliers, I think it'll come right out. Yeah, there it is. Let's roll this back so we can look at it. So there we have our guide kind of broken up on top. Let's face that off so it's nice and flat, and then we'll head out and see if we can build something similar to what this looks like. This tool is not properly piloted, but I think we can serve the purpose of just cleaning that top edge off. There, we just touched off on the head itself. Good enough right there. So, I guess it's time to go to the lathe and do some work there.
So most of you guys know that the lathe is brand new to us. This is like one of the first times that my dad has ever actually ran the lathe. And I was actually at home with the new baby, so I wasn't there to help walk him through this, but I was actually impressed. He managed to get the thing turned on and get the part made for the replacement, or for the repair here. But because he wanted to focus on running the machine and not having any issues, since, like I said, it's a brand new machine, he didn't bother with setting up the camera, because it actually, believe it or not, adds a new layer of stress when you're recording. But had his little drawing that he sketched out, went and found a camshaft to use for some material, and set up on the lathe there and machined out a little guide chimney, basically. He actually made two of them, screwed up one of them because he forgot to turn the chamfer feature off on the Haas lathe. But like I said, luckily he made two. And then he pressed the new valve guide into that chimney, and then pressed that kind of assembly into the cylinder head. And when it was all said and done, it looked brand new. You might remember from the previous video, on most of them, he put the shorter piece of the guide on the top side of the head. On this one, he ended up putting it on the bottom. So, like I said, he didn't end up recording any of that, but we wanted to go in and add some pictures of it at least. Just kind of one of those things that he wanted to be focused on the work rather than messing around with the camera when I wasn't there to help. So, came out to be a pretty nice repair, but unfortunately there's not a lot of video covering it. So,
now that I have the guides, the new seats, and the head gasket surface done on these heads, I need to pay some attention to the exhaust gasket surface. These heads have evidently been sitting out for quite some time in the weather, which is to be expected on an old tractor like this, but it has really eroded this area away where the exhaust manifold is going to seal up. So I want to see if I can set up this fly cutter here, and we'll make a pass across these heads and clean that surface up so that the exhaust gasket will seal well again. So this first pass, I set it to take about 2.5 thousandths off. I know that won't even come close to cleaning up, but it'll give us a good idea of whether or not I have the head square on the machine as it should be. Okay, let's take a closer look at what 2/1000 has done for this. On that port there, cleaned up better than I thought it might, left a few little pits. This side over here has quite a bit to go yet, but it does look like we're square with the machine. Everything's cutting as it should. So let's go ahead and take maybe another 5/1000 off there and see what that looks like. Okay, that pass there made a considerable difference. We still have a few pits down in this area here, on this port over here. This stuff right in here is quite deep. I don't think we'll be able to get rid of all of that, but we can do a little bit more good up on this area in here. So let's take 5 more off of that and probably call that good. that port cleaned up absolutely perfect. This one, we've still got some stuff around the edges here, but we're just going to have to live with that. There's plenty of surface beyond that where the gasket will seal. I don't think that'll ever be an issue, because if we attempted to cut deep enough to get rid of that, we would have too much off the head, and it is not worth the cost or the effort to try to build that up with weld or anything like that. So we're going to let it go as it is, and I think things will be fine. So now we need to just repeat this process on the next two heads, and I will take exactly the same amount off of the other two heads. Some engines where the manifold bolts up across all 6 heads, and also the intake on the other side, you have to keep that distance the same across the heads here, otherwise the manifolds won't line up right. I don't know if that's the case on this engine or not, but I'm just going to do it that way, and that way, if that is the case, we will not have an issue. Okay, as you can see there, I've taken the same amount off of each head, 12 thousandths total, and that was based on what this head here that I thought was the worst one, and I took what I thought was a reasonable amount to clean it as well as we can without being excessive with it. So that is the only port that did not completely clean. That one looks good. Both of these look good, as does these here, and all equal the same, so the manifolds should still bolt up and not give any issue to the customer. Okay, we're coming up on the last step of building these heads. All that's really left as far as machine work is to finish the valve seats. I've got them mounted up here on the SERDI, and I have my specification book here from Gen Sales. Again, I want to thank them for sending this out to us. All the information I need is in here. This here all talks about finishing the valve guides, finishing the valve seats. So we'll kind of go off that and get our equipment set up here so we can do that. When we were initially checking these heads out, we did magnaflux them, and I did determine that they do have one small little crack in here that I'm not going to worry about too much. It's more just a heat check, but we have questions all the time, people asking us to show them what a crack looks like when you magnaflux a head. It's a magnetic yoke we put across here, turn it on, and I sprinkle just a little bit of iron filings, and there you should be able to see that. There's just some little heat checks started there that someday may turn into an issue. But at this point in time, I don't feel like they're big enough to cause any problems. Does not even go all the way across the area here between the valves. Goes down maybe 1/4 of an inch there below the head gasket surface. Now, if that was twice that big, I would start getting concerned, because there is probably a water passage between those valves that could let leak. But at this time, I have no indication to think that it's been leaking, nor do I think it'll leak as this goes back together. So we're going to let it go. We will point it out to the customer. I mean, if he looks at the video, he'll see that it's there. But now you know what a crack looks like when you magnaflux it. I have adjusted my cutter here close to what I think the diameter should be to match my valve. And I guess what I need to do is start out, just make a rough cut and see how things look. So we'll get this all centered up where it needs to be. Float the head here so it centers up on that valve guide. You can see I've initially cut my seat there. I may not quite have the full width, but we're close. Black marker. Put a little on the valve seat itself. Use our lapping stick, even though there's no lapping compound there. Rub those back and forth on each other. And yeah, we need to go out quite a bit. I'm seating way inside on the valve face there. So I'll adjust my cutter out and we'll try that again. We have our seat width across here, which is 45 degrees. We have our bottom line angle that narrows it up, and we have just a sliver of the top angle there. So now let's check where we're contacting the valve face. There it did. So you can see here on the valve seat, it's now shiny again. It's taken the marker off all of the valve seat, and my valve face is pretty much the width of the face, but I do have just a sliver of black on the inside and a sliver on the outside. So I'm matched up. My seat and valve both match. So now I need to check the depth, and it would be nice if it gave me a specification from the face of the head to the face of the valve, but it didn't. It gives me a specification for valve spring height. So I'm going to have to put the retainer and keepers on here on the bottom side, and then I have taken this bolt here. My specification is 2.940. And I have adjusted this double nut on this bolt so that the overall measurement here is 2.940. So now I'm going to go on the underside and compare that to my valve spring area and see how close we are. Boy, we are very, very close. We're a little bit tight. I'm guessing 10 thousandths. So let's go ahead and cut that seat just a little bit deeper. Come down and just touch off on that seat. Reset my zero. And now I'm going to go down 10 thousandths of an inch. Reading that off my DRO. I don't know how well that shows, but going down the additional 10 thousandths, my throat angle in here stayed virtually the same. My seat angle, 45, is the same, but my 30-degree top angle here has increased quite a bit, because the seat has dropped, the sealing surface of that seat has dropped down in. So let me put my retainer back on. We'll eyeball this on the underside, see how it looks. I wish I could show you all this, but working here by myself, I just don't have enough hands to move that camera around and show all the detail that I'd like. We're sneaking up on it. Let's go an additional 10 thousandths. I'm not quite there yet. There's where we left off last time. I'm going to give it 10 thousandths more. And there we have it. My reading I'm taking down below here between the retainer and the spring seat is just about exactly where we need to be. You know, I could probably go 5 thousandths more. Okay, there's where we left off the last time. So we're going to go 5 more. There we are. Now that we have our depth where we want to be, the rest of them are going to be easy. I'm going to take my deck bridge gauge here. And I'm going to measure what we've got. Now 0 there. Come over to the face. Now I've got about 52 thousandths. 50 to 52 is where I would like to come out. I'm going to write it right there, 50 to 52. So now watch how quick we can get this other valve done. Okay, again, this valve here, gauge set on 0, move over here, I'm about 52, move over this hole, see how it measures. Zero. Look at that. Maybe ever so slightly. No, we're right on 52. They're both just like. So that shows you, now that I have the first one set, how easy it'll be to do all the rest of them. So I think with that being said, I'm going to go through, do all of the intake seats. It's a little bit of trouble taking the head on and off here, but we'll switch them around, do all the intake seats, and then we'll come back and clean up the exhaust seats. Back when I was installing these valve seats, do you remember me saying something about I was going to fudge and bring them up just a little bit so we had plenty of meat to work with? Well, we did that, and after I got done cutting these, I shut the camera off and I came back over here and looked at it again. I don't like the way I left this. There's quite an edge here right at the top. If I come back with a cutter here that will top that off with a radius here, I can get rid of this sharp edge and blend that in much better. Is it going to make any difference? Probably not, but it makes a difference to me. I don't like the way I'm leaving this. So let's come back and top those off. It'll just take us a couple seconds here. It's not a big deal. And see if we can make that look a little bit nicer. I want this to be something I can be proud of when the next guy looks at my work. Yeah, just that little bit really cleaned those up. Makes me feel a lot better about the way they look. There, we have all the intake seats done, and I think you'd have to agree that went exceptionally well and exceptionally fast. After we got the first one done, everything set up, we just buzzed right through the other 5 just with the measurements we'd taken on the first one. So yeah, the first one's sometimes kind of difficult to get right, but once you get it right, all you have to do is make the others match. So now we got to do the same thing on the exhaust. Again, the exhaust will be the same width as the intake. Book calls for 3/32 of an inch. Since these are buried down in there so deep, they're probably about 1.25 inches deep down in there. That's going to make it really hard to set up just eyeballing it the way I did the first ones. So this one we'll actually use the fixture to set our cutter diameter. So I'm going to use this tool here, and I'm going to set this so that pointer is right about where I want the outside edge of that seat to contact the valve. This one here we did not put new exhaust seats in. We're going to reuse the existing seat. It appeared to be in good enough shape. I didn't feel like there was any reason to change them. This pilot is probably less than 1/2 thousandths smaller than the valve guide itself. Very close fit. That's why it always has to be lubricated. And like I found there's just a little bit of a cutting gut down in there, and that's all it takes to keep it from going in. I'm going to put some black marker on the valve seat itself, put some on the face of the valve. We'll rub those two together so they rub the marker back off. That is just about exactly where I want it to be. Now, nothing at all wrong with that contact area, but my contact on the seat itself is a little bit narrow. I'll show you this here in a second, but the inside of this seat is probably a little bit larger than I would like to have it. There's no material there. Once again, this is one of those times you have to work with what you've got. So despite the fact that I like the contact area on the valve itself, I'm going to go ahead and open this up a little bit so I can widen out my seat contact area. Okay, I think I have just got my top angle. I hope you can see that, because it has cleaned up my seat area and has just a sliver of the top angle. You can see that area right across there. That is my full seat width, and it probably doesn't show on the camera, but that top edge has just brought on the 30-degree top angle. So now let's go back and put the black marker on that and mark our valve, see how that looks. I did not realize you were out of focus, or I would have done something about that. But when you're trying to do the work and run the camera, there are trade-offs, so please bear with me. There we go. Maybe a little bit farther out on the valve from what I would prefer, but again, we have to match the seat. I don't have material on the inside to bring that in anymore, so I'm okay with that spot. So now that we got that set, we should be able to buzz right through the rest of them just about as easy as what we did on those intakes. So I'll do the other exhaust here. Well, we're back on the Minneapolis Moline heads this morning. We're waiting on the spray cabinet here to get hot. We've got it fired up. It has a gas burner in it. It'll take a couple hours to get the solution up to temperature. And once it is, we'll put our heads in for a final wash, get all the cuttings and any residual glass beads and anything like that washed out of them for when we did clean the heads. In the meantime, I have the valves over here on the bench. Our customer was able to source all 6 intake valves, but only 4 exhaust valves. And actually our intake valves were the worst of the 2. The exhaust valves here are not anything special, the old ones, but I've certainly used worse. So I think what I'm going to do is go ahead and go through and grind all 6 of those old exhaust valves, and once they're ground, we'll make some comparisons and pick out the best 2 to have to reuse in these heads, since we were unable to source any new valves for them. Okay, I'm going to start by hand polishing the keeper groove area here on these valves, and then I will move on to polishing the entire stem. They actually don't look too bad here. I think I'll go ahead and measure them here real quick. Slightly under 434 thousandths, 433, 433, a little over 433, that was a little closer to 434, slightly under 433. I believe that's probably within our spec. I'll have to take a look again, but let's move over and go ahead and grind them and see what they look like at that point. Here I'm going to show you grinding the tips of the valve where the rocker arm contacts them. It's always good to have those nice and square so the rocker arm glides very nicely across the end of the valve, doesn't pull it sideways or anything, wipe out valve guides. And also if they're rough, uneven, it's almost impossible to get a good valve lash adjustment. This machine does kind of sit in the corner of the shop here. It's a little bit hard to get at as far as taking any pictures of it here, shooting any video. But what I'm doing here, I hope you can see that, is putting a valve guide in the fixture on this machine so that I don't have to clamp every single valve in as I go. All I have to do is just slide them in and out. So I'll slide up, rotate the valve against the stone like that, and hopefully I end up with a nice non-directional finish on the end of that stem. Looks like that one could stand just a little bit more. Yeah, that looks better. No specific amount has to be taken off, just enough to clean the surface so we know it's nice and flat. See if I can get you a little bit better close-up view of that, if I can find it here. Get the camera to focus on that. Sometimes if there's burrs on the edge here, you can turn this to the other direction here, coming at an angle, and you can chamfer this edge on the machine. But these here, they still have quite a large chamfer on there. I'm not going to have to worry about that. So now let's reposition and we'll see if we can grind the face of these valves. And here I have the valve grinder set up to grind the valves. I've set my angle, I've set all my stops, I've adjusted the wheel up. Like I say, this is a bad spot in our shop to get to with the camera. But let's grind these, we'll see. Just want to move kind of slow back and forth across the valve use the entire width of the stone. Just gradually feeding the valve into the wheel. Let it spark out just a little bit. Let's see what that looks like. Right in there, there's still some pits. So we've got to go just a little bit more with that. See how that looks. Well, I believe that got it. Now it looks like it got everything except one little pit up here on the edge, but I believe that is actually outside of our seating area. So I'm not going to worry about that one. I'd sooner leave the extra metal on the valve. See there, as I start grinding, it cleans up everywhere except in the middle there where it was seating. That looks good. I believe that's good. Whoa! Why is that valve so far off? I think that valve has a lot more meat on it. It's not nearly as thin as the first four we had ground. That's probably going to be one of our better valves that we may want to use. There, that looks good. Last one. Okay, that looks good. That valve almost appears to be slightly bent. It's clean on that side, nowhere close there. We'll go ahead and finish it out here, but we may mark that one as one we do not want to use. Yeah, it actually has a spot in there that appears to be bent, or appears to be burnt and possibly bent. Probably it started burning and then warped real bad. I'm not going to finish that valve. We're going to definitely not use that one. I don't like the looks of it at all. So now the other thing we're going to want to do is grind our brand new valves. Probably not a necessity, but we do find sometimes that the new ones are off just a little bit. I'm going to put some black marker on the face of our brand new ones here. That'll help give us a visual and see whether or not we're getting them ground true. And just sometimes, you know, when they're brand new and everything's shiny, it's almost impossible to see where you're grinding anyway. So by putting the color on there, it makes it real easy to see what's going on. There, you can see that cleaned up almost immediately there. There's not enough difference that I would have worried about that to have had to reground that valve, but it's always good to check. Seems like it takes less time to just up and do it than have to come back later and touch them up when they won't pass the vacuum test. Yeah, that one's all but perfect. That one I'm off just a little bit. You can see there, touching just one side. Let me reposition that in the chuck. make sure it's not an issue with the way I have it chucked up. Yeah, it's off ever so slightly. At that point it's clean already. So let's move on to our new intakes here. Okay, the intake valve is a little bit longer, so I'm going to have to adjust the stop so I can bring that valve back in a little further. About like so, I think is a good spot. And we'll bring the grinding wheel over and adjust the stops so that I can use the entire face of the grinding wheel, but not crash the wheel into the stem on the underside of the valve head. That's an absolute no-no. If you crash one like that, it'll leave a little groove, and I'll guarantee at some point in time that valve will break right where that groove is. Now you can see on that one, our angle is just a little bit different than what that valve was ground when it came from the factory. We are making these at exactly 45 degrees. The book called for 45 and 46 interference, but we're going to put both the valve and the seat at 45 degrees. I do not believe, on most of these engines, I do not believe in the interference fit at this point in time. That's kind of an old school thing that was done years and years ago, actually probably when this engine was new. But the fuels we have now are much cleaner. Our equipment is much better. We can do a better job of having the valve and seat match up with each other. You just don't need that interference angle any longer, because what it actually did was it helped the valve to cut its way into the valve seat and seat itself, because most of the equipment that was being used was of such inferior quality. I mean, it's as good as they had back then, but it was inferior to what we use nowadays. And I'm sure there'll be somebody argue that point with me, and that's okay. I have my opinion, they have theirs. What I'm doing here works for me. Maybe what you're doing works for you. So just let it go at that. And there we have it. All the valves are ground. Now it's just a matter of picking out which two of those exhaust valves we want to use and waiting on the heads to get clean this morning. I may go out and see if I can get my tractor ready. I'd like to do a little bit of farming this afternoon. Okay, now that we have our valves ground and the oil wiped off them, let's make some measurements here and see if we can determine which ones we want to use of these exhausts. Our specification in the books here says valve stem diameter should be 433.5 to 434.5. We'll measure a new valve here, just see where it's at. Just shy of 434, top and bottom. That's right in spec. This valve here, just over 433, so it's a little bit shy on size. 432.5, so that's down there a little bit. 433, that's probably one of our better ones up to that point. 433.5, that's a better one. 433, maybe not quite a half. Okay, so those three stems seem to be our better ones. Let's look at the face of them. This one does have a nice thick face. Actually, that's the one earlier I crashed the wheel into the edge of it, because it is, I think, quite a bit newer valves than the others. Has not been ground as much. So I did leave a little witness mark there at the edge, but it's not where it'll bother anything. So I think that's definitely a valve we want to use. Now let's see between these two. They don't appear to be curling up. I noticed on one of these, that one there, you probably can't see that on the camera, but if I run my finger across there, I can feel where the edge is starting to curl up on that, maybe a little bit on that one. So let's set those aside, go back to deciding between these. Feels good on that side. The thickness of the margin, kind of a toss-up. No necking on either of the stems. Sometimes the valves will actually get hot enough they start stretch and they neck down in this area and will eventually break. I guess I'm going to go back to, let's make a determination by the stem size. So there's 433, not quite a half. 433, not quite a half. Boy, the same way. That one is just 433 at that point. This valve here, the stem, is probably just ever so slightly better. Let's go with that one. We'll use those two right there to make our set and let the customer save those in case they ever need them again. And with that, I guess we're going to stop here for a little bit because I do need to wait for the spray cabinet to get hot and wash those heads. And we'll come back maybe a little later this afternoon and finish assembling. Well, I think the spray cabinet is hot. It's been heating up here for a couple hours. Oh yeah, definitely hot enough. I actually kind of overdid that. It's actually boiling. So let's get it opened up and we'll put the heads in. We're going to let those run while we go to lunch here. Once we come back from lunch, we'll get them out, dry them off, see if we can put them together. Okay, I think these heads have run long enough. Let's get them out, rinse them off, see if we can get them put together. I don't know about you, but I'm ready to be done with this project. When we do a set of heads like this, I always go through on the final wash here and try to wash out every single opening on the heads. All the blow holes, all the ports, just anywhere that there could be any residual clean abrasive or grease or dirt hiding out. Very important that you get your parts clean when you're done. So now we're ready for the fun part. We've got the machine work all done. I'll have to wipe this off a little bit before I completely finish here, just to make them look a little nicer. It's kind of the way they look after the water stains as you rinse them off. I've got all my parts laid out, all 12 valves, 12 springs and retainers, all my keepers here. Interesting thing these heads have is a snap ring here that literally just goes around the valve stem after you put the valve in. It doesn't have a groove or anything. It goes in, just rides up and down with the valve, but it fits tight enough that if the keepers were ever to come out or the top end of the valve broke, it would keep the valve from dropping down into the cylinder and causing pretty severe damage. Unusual as far as automotive or passenger car and truck engines go, but I see that a lot on these older tractor engines. This being Minneapolis Moline, I've seen that. Els Chalmers International, they all use Clips of some kind, just kind of as a safety in case things broke. It would keep the valves from dropping clear down into the cylinder and really causing some severe damage. So I'm going to set the phone up here on a tripod and we'll start assembling these. Okay, guess we'll lube the valves up, put them in. Since this is just a stock tractor engine, nothing real special about it, they're just trying to make it new again, we're just going to use ketchup for lube. Sometimes when we do a performance engine, we do use the sriracha sauce or spicy lube. Seems like it makes the engines run a little bit better and go faster, but this being stock, ketchup will be just fine. There's our intake valves are all in. See if we can get the exhaust in. One little thing I do here, when I put the lube on, I actually put it in the keeper grooves. That way when I shove the valve in, it helps pull a little bit of lube on down the stem with the valve, plus the keeper grooves are lubricated to the very top there, so that everything goes together a little bit easier. We do need to install valve stem seals on the intakes. A lot of times we put seals on the exhaust also, positive seals, but I actually found in that service manual where it says when these engines were new, they used seals on some of the exhaust, but it must have dried them up too much because it says remove the seals. Yeah, it said remove the seals from the exhaust, do not reinstall. So we'll do that, just put them on the intake. I found a little bit of brake parts cleaner on there. Makes a seal like this slide on real easy, and then they kind of stick in place. These are just a little bit different than the original. Original on these was a rubber banded type seal with a Teflon insert. These are a Viton seal with a garter spring around the top. Product we get from SBI. They are one of our sponsors. We use a lot of their stuff, and we have for many years. I've probably been using their products since probably clear back in the 80s. Probably long before some of you people watching this were even born. So the seals are all on. And you saw how easy those slide on, but now that they're on, they are snug. I mean, I could pull that off, but they are on there to stay. They're not going to go anywhere. So now I need to get these clips put on. So all I need to do is just open that up just enough to slide that down over the valve stem, and we'll put it a little bit towards the top here because we don't want it to push down and hit the seal. When we put the retainer on, it will push that down far enough to get the keepers in, and that's where it will just ride for the life. Exhaust here, I'm going to have to pull the valve up a little bit. There we go. A lot of times you'll see heads come in where someone has worked on it, and something simple like these little snap rings that serve no purpose other than if there was a failure, the guys will get sloppy, get in a hurry, leave them off, not put them back on. But I always like to put them on there. If the factory thought they need to be there, I think they need to be there too. And furthermore, if you was to have a failure and had not put those on, I could see yourself in today's world ending up in a court of law with a claim against you for the rest of the engine that got destroyed when that valve dropped down, if they could prove you had not put that clip on there. So it's just not worth a little bit of savings in time to not put everything back the way it's supposed to be. So now we should be ready to put the springs on. These are quite large, bigger than my C-clamp likes to work with as far as the diameter. If you also look at that spring, you'll see that the coils are wound tighter down here at what is the bottom side. My understanding is that is to keep the heat from traveling so far up into the spring, because as the heat starts coming up, it has to follow all those coils around before it gets up into the coils that are actually doing the work of keeping that valve closed. So I'm only going to pull that down just far enough to get the keepers in. Okay, we have all the springs on. You can see some of those clips down in there did slide down a bit far, and I'm afraid those may end up hitting the valve stem seal there. So I'm going to go in with a screwdriver, I think, and see if I can't push that clip a little bit further towards the top. Yeah, that would not be good if that clip was pushing down against the valve stem seal. It would destroy that pretty fast. There, we have them up out of the way. Okay, last thing, we need to put the expansion plugs in the ends of the heads here. These heads just use a flat concave style plug. Sometimes you gotta make do with what you've got. I had 5 steel ones on hand, 1 brass. Brass ones would never ever rust out. However, if the steel plug's in there, if they'll run some good antifreeze in this, they'll never rust out either. So what I gotta do is put a little Loctite around there, drop these in, and then you hit them with a hammer to flatten them out. I'm using some sleeve and bearing retainer here. My bottle's quite low, so I'm going to have to apply it with a Q-tip here. Just want to coat the inside of that opening. And hopefully the plug will just drop into place here. Sometimes they're a little bit tight to get in where they belong. The way these are retained is, since they are concaved, when you get them installed and then hit it and flatten it with a hammer, it expands the plug outward to hold it in place. So the last thing you want to do is tap very hard on it here, trying to put it in, because you'll actually expand it enough that it won't go in. And I'm wondering if that's going to be my trouble here. No, there it goes. Sometimes just a little bit of encouragement helps it go in. But there, that one is in place. Just need a little encouragement. So now we have to flatten that plug. And that right there should be enough to retain it. You don't want to go too far, because you'll go over center and turn it into a convex going in rather than coming out, and it'll actually be loose then. There, that feels pretty good. connectors, I've got them all down in where they belong. So now we just have to flatten them out a little bit so they retain and stay. Okay, there we are. Complete. One last thing to do, and that's carry them over here and do our vacuum test on valves, make sure they are sealing as I think they are, and they'll be ready to call the customer and they can get their tractor together. Here is the final test of my heads. We're going to turn the vacuum on here on the SERDI. Stick this over the port. I do have a vacuum opening on the top side of this head that I have to cover with my finger. There we go. Doesn't get much better than that. Go over the exhaust port here. And there we have dang near perfect vacuum. I'll just show you, turn that pressure off or turn the pump off here. Ever so slight leakage, which is probably through my valve guide, seeing as how there is no seal on these guides. Okay, there we are on the other exhaust port. And again, darn near perfect. I can shut the pump off and show you that it virtually holds. It's gradually creeping down, but that's what I would consider very acceptable. Okay, so now we need to check the other two heads here. Connected over the intake. This one has a plug in this area here. I think that's where the it acts as crankcase ventilation, pulls a little bit of the crankcase gases back into the intake on these. We're pulling as good as it ever gets. There's the next exhaust port. Again, vacuum is good. The other port doing the same. And again, this is one with the opening up under the valve cover. I have to keep my finger on that. You can see we're pulling good vacuum. Back on the exhaust, needle coming up, looks good. And the last exhaust, that goes above the 7 on there. I'll be happy, and it has. Nothing at all wrong with that. You can see, turn it off, it pretty much holds. Yeah, no reason that won't work. The finished product, one of the 3 heads from a Minneapolis Moline G1000 diesel tractor, 504 cubic inch, just shy of 100 horsepower at the drawbar. This head probably came off a tractor out of the early 60s. We'll go back together, customers restoring the tractor. Even if this tractor was put into service, I'll bet this head outlives me and the owner. Came out very nice. Very pleased with the work on this. Beautiful head.